So now in this part we will learn about static and dynamic data structures. Okay, so let's start with static data structures, and in static data structures we will learn about arrays. So what is an array? Array is a linear data structures where all the elements are arranged sequentially, and it is collection of similar collection of elements of similar data type, okay, and stored at contiguous memory location. So similar data type means if you can see here, all the data elements of this array are of integer type, and or integer type, there is no different data type that's stored in this array. And what do you mean by this contiguous memory location? Contiguous means one after another, adjacent to each other. For example, if we have an array A of integer type, and we know size of integer is 4 bytes. So if there are the elements 1, 2, 3 and 4, and it start from the memory address 1001. So what will be the address of this data element? It will be 1001 plus 4, that is 1005. And why we have taken 4? Because it's the size of an integer, which means this taking 4 bytes, 1 2 3 4, 1 2 and 3 4. That's why if it's starting from 1001, it will be, then it will be 1002, 1003, 1004, and it will start from 1005. Okay, it will start from 1005. And that's the thing what we call contiguous memory location, which means the data is present continuously, and there is no, you cannot see a breakage between them, which means data are present adjacent to each other. And you cannot find, if you cannot say that if you are finding 23 at 1001 location, then it will be always present in 1005. You cannot say it will be present at 1009. That will be wrong. Okay, so now we will learn about dynamic data structure, and firstly we will learn about the linked list. So what is a linked list? Linked list is a fundamental data structure in computer science, and it mainly allows efficient insertion and deletion operation compared to the arrays. Okay, so and a node of a linked list consists of the two parts. First part always stores data, and second part always stores the address of next node. Okay, or we can say it points to the another node. So how it is more efficient for insertion and deletion operations in linked list as compared to array? Because unlike array, the nodes of the linked list are present in different memory location. For example, if the first element node is present at 1001, then second element can be present at 1000, okay, or third element can be present at 1025. There is no contiguous memory allocation. Okay, now when we are trying to insert a data, so what we will do, like this is an linked list 1, and it is pointing to the another node 2, and it's pointing to the another node, that's 3. So if we want to insert a new element here 4, so how we will do it? Firstly, it will be same, it will be point 2, and now this second node will be point to the node 4. Okay, let me show you here. It will point to the node 4, and this 4 node will point to the third node. Okay, so This is how insertion is so easy in linked list. For deletion, we can say that, like we have, if we have a linked list 1, it's pointing to 2, pointing to 3, and if we want to delete this node, so what we will do is just, here will be 1, here is 2, here is 3. We will store the address of third node here, not the second node, and it will get disconnected, and it's connecting to the third node. It will, then we will delete this thing. Okay, so this is how deletion is easy in linked list. That's why linked list is more flexible than arrays. Okay. Now we will learn about queue. So what is a queue? A queue is a linear data structure where elements are stored in FIFO principle. According to the FIFO, what is the FIFO? First in, first out principle. And the first element inserted would be the first element to be removed or accessed. Okay. For example, this is a stack. This is a queue. Okay. Firstly, we have inserted 1. Then we have inserted 2, then we have inserted 3, then we inserted 4. Or we can say that firstly we have push 1, then we have push 2, then we have pushed 3, then we have pushed 4. So when we will use the function of pop, then this one will be the first element which will get pop out. Okay, that's why it is known as first in, first out, which means the data element which is inserted first will be the first element which will be popped out from the data structure. Okay. Now we will learn about stack dynamic data structure. So a stack is defined as a linear data structure that is open at one end and operation follow at the last in first out order, which means the element which is inserted last will be the first element which will be popped out. As you can see in this diagram, here is already 2, okay, in our data structure. Then we have pushed first data element 1, okay, and when we are using the pop function, then 1 will be the element which will get popped out, because 1 is the last element, inserted to data structure. Okay, that's why stack uses the concept of LIFO and queue uses the concept of FIFO. Now in the next part, we will learn about nonlinear data structures, abstract data types, and data structure operations. Thank you.